Good morning to all my good students. Now let us study the grade 9 science chapter sound. Sound is a form of energy which produces a sensation of hearing in our ears. What is sound? Sound is an energy. What are all the other types of energy? Mechanical energy, heat energy, light energy. All these energies are traveling in the form of waves. The light is traveling as a waves. Similarly, sound is also traveling as a wave. So what is meant by sound? It's a type of energy, it's a form of energy which is producing a sensation of hearing in our ears. How we are creating sound? We are all human beings. Sound is created in an organ called vocal cord. Right side you can see the picture of vocal cord. This is the vocal cord. Sound is produced due to the vibration in the vocal cord. When the vocal cord is vibrating, sound is produced. You might have seen how birds are creating sound when their wings are flapped. When a bee is buzzing, how sound is created. So we have to know sound is produced by vibrating objects. The wings are flapping. What is created? Sound is created. A sound is traveling through a medium. What is meant by medium? Medium means a matter or substance through which a sound is transmitted. Medium may be a matter or may be a substance. What are all the different medium through which a sound is transmitted? They are solid, liquid or gas. Sound can travel through solids. It can also travel through liquids. Similarly, sound can also travel through gases. So a question arises. Sound travels fast in which medium? Sound travels fast in solid medium, followed by liquid and followed by gas. So we can see here sound is traveling faster in solids. Why sound is traveling faster in solids? It is because a solid contains many particles which are tightly packed. All of you know very well, in a gas, particles are not tightly packed, loosely packed. But in liquid also, particles are not tightly packed like solid. In a solid, since particles are tightly packed, it is easy for sound to move from one particle to another because all are tightly packed. So faster it will move from one particle to another. So we can see here sound is traveling much faster in steel than in water or air. Why? Steel is a solid matter. In steel, particles are tightly held together. How really a sound is traveling? In air, sound travels. Most of the time, sound travels in air only. Even though air travel faster in solids, Majority of the time air is traveling in sound is traveling in air. How actually the sound is moving? When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. You can understand if you look at this picture. This is how a sound is traveling. If you look at the front side, in the beginning is tightly packed, then is loosened, then again it is tightly packed, and again it is loosened. So there are mainly two types of waves. First one is called longitudinal waves, and second one is called transverse waves. What is the meaning of longitudinal waves? We can see here, we can see this picture and understand the difference between longitudinal waves as well as transverse waves. In longitudinal waves, which is found in the upper picture, sound is traveling parallelly, isn't it? It is oscillating back and front. You can see here. But in transverse wave, what really happening? It is oscillating up and down. So what type of waves sound is? Sound is a longitudinal waves. In longitudinal waves, you can find compression as well as rarefactions. From the name itself, we can find out what is the meaning of compression as well as rarefactions. So in this picture, C stands for compression, R stands for rarefaction. Here sound waves are tightly held and compressed. In the R region, we can see it is not that much compressed, and it is continuing. So we have discussed here there are two types of waves, longitudinal waves as well as transverse waves. Sound waves are longitudinal waves because it is vibrating back and forth in the same direction. It is not going up and down. It is not oscillating up and down. It is oscillating back and forth in the same direction. What are some of the key characteristics of longitudinal waves? When particles are closely held together, that region is called that is compression. But there is one more area where particles are kept far apart. That area is called rarefaction. We can understand compression and rarefaction from this picture. C stands for compression, R stands for rarefaction. As we discussed, there are two types of waves which we have to discuss. Second type of wave is transverse wave. Light is a transverse wave. Light is an energy. Sound is also an energy. Light is also an energy. So here, what type of waves which is produced by light? It is transverse wave. In a transverse wave, as we told, the waves are oscillating up and down, isn't it? It is not oscillating back and forth. The upper portion is called crest, and the downward portion is called trough. Both are deviating from the main portion, main lane. So here it is called transverse waves. So from their mean positions, we can see here how it is in the upper position, how it is in the lower position. Upper position is called crest, lower position is called trough. This is the mean level. We can see from this picture how far the crest and trough from the mean level. Light, water and all follows transverse wave. When we are throwing a stone into the water, the ripples it is creating, what type of wave it is? It is transverse wave. What are some of the important characteristics of transverse waves? The highest point of the wave is crest. We already discussed. The lowest point of wave is called trough. What about the wavelength? What is the meaning of wavelength? It is the distance between two corresponding points. That means two crests and two trough of a wave. Then what is meant by frequency? The number of waves that pass a given point in a unit of time. What is the meaning of frequency? It means the number of waves that is passing a given point in a unit of time. You can see that through this picture. The height of the wave is amplitude. When you are hearing a louder voice, amplitude will be taller. When pitch is higher, amplitude you can see here. And when pitch is lower, how amplitude is changing. So characteristics of a sound wave. How we can describe a sound wave? We can describe a sound wave by its frequency, amplitude and speed. What is meant by wavelength? It is the distance between two consecutive compression or two consecutive rarefaction, isn't it? We have learned what is the meaning of compression, what is the meaning of rarefactions. Both are two different regions. So actually the distance between two consecutive compressions or two consecutive rarefaction is called wavelength. You can see here the wavelength, which is marked here through this arrow. Amplitude, height, we can see here. Frequency, how frequently waves are traveling. In the case of high frequency, you can find more waves. In the case of low frequency, you can find less waves. We can see here the wavelength. In the case of higher frequency, wavelength will be shorter. In the case of lower frequency, longer wavelength, you can see here from this picture. We can see the different types of frequency, low frequency here, medium frequency as well as high frequency. What is the meaning of frequency? It is the number of waves that pass a given point in 1 second. The first example, frequency is lesser. Second example is a medium frequency. Third example, high frequency. The right side you can see two types of waves, transverse waves as well as longitudinal waves. Sound is what type of waves? You have to answer, and you also have to answer second question. Give two examples for transverse waves. What is the SI unit here? SI unit of frequency is hertz. So what is meant by frequency? In general English, frequency means how frequently an event occurring. Suppose we are beating a drum. How often we are beating? In a unit of time. So you can see this picture. What is 1 hertz? 1 cycle per second above and below the atmospheric pressure line. Hertz is marked here through this arrow. What is meant by time period of the wave? It is a time taken by two consecutive compression or rarefaction to cross a fixed point, isn't it? It is the time taken by two consecutive compression or rarefaction to cross a fixed point. It is called time period of the wave. What is the meaning of pitch? How the brain interprets the frequency of an emitted sound. It is called pitch. Pitch is an important element when it comes to music. Music directors are giving high value for pitch. How loudness or softness of a sound is determined? It is determined by its amplitude, isn't it? How amplitude of a sound wave is determined? It is determined based on the force with which an object is made to vibrate, isn't it? You can see here the amplitude of a quieter sound as well as a louder sound. What is meant by timbre? It is again another quality which is highly valued by music directors. It is a characteristics which enables us to distinguish one sound from another having the same pitch and loudness. Through a timbre, we can distinguish one sound from another with same pitch and same loudness. What is the meaning of a tone? Sound of a single frequency is called tone. Tone means the sound of a single frequency. We have learned what is the meaning of frequency. What is the meaning of intensity of sound? Amount of sound energy passing each second through a unit area is called intensity of sound. Sometimes we call it as loudness. And the word loudness and intensity interchangeably we are using. But in reality they are not same. What is loudness? It is the measure of the response of the ear to the sound. How our ear is responding to a sound. That measurement is loudness. Sometimes there will be two sounds of equal intensity, but our ear hear one sound as louder than other sound because our ear detects that sound in a better way. Speed of sound in different media. As we have discussed earlier, sound can travel in different media. isn't it? And sound travel fast in solids, then in liquid, followed by air or gases. You might have seen or heard, when there is a thunder, the sound of the thunder reaches only after lightning. Why? Isn't it? It is because of change in the speed of sound. We can make out that sound travels with a speed which is much less than the speed of light. Speed of sound depends upon properties of the medium through which it travels. When there is a lightning, we hear it first. Sorry, we see it first. Then we hear the thunder later. Why it is so? Because light and sound both are energy, but light travels faster than sound, and sound reaches our ear only after the light has passed. Now let us learn the concept called sonic boom. What is the real meaning of sonic boom? It's a loud sound. You can hear it in war zone and all. It occurs when an object travels through the air faster than the speed of sound. When any object is traveling at higher rate than the speed of sound, we can experience sonic boom. The speed is approximately 767 miles per hour. What are some of the characteristics of sonic boom? Loud sound. Sound will be very loud. It will be much louder compared to thunder or explosion. It happens suddenly. It can startle the pupil. People will be worried when they are hearing sonic boom, and happens for a brief duration. Last few seconds only. What are all the effects of sonic boom? It can damage property. Sometimes if there is a sonic boom, especially on war places, we can see the windows are cracking or breaking. It can create damage to building or windows through its sound. No need to explain noise pollution. It is a major source of noise pollution in war zone and other places. It will disrupt pupils' activities. What are all some of the common causes of sonic booms? First one, military aircraft. Because many aircrafts are traveling faster than sound. Missiles and sometimes meteoroid. When meteoroids enter Earth's atmosphere at high speed, they can produce sonic booms. Now let us learn what is the meaning of echo. When we are shouting or clapping near a reflecting object like tall building or mountain, we hear the same sound again little later. It is an echo. Why the echo is happening? Because the sensation of sound persists in our brain, remains in our brain for about 0.1 seconds. Reverberation. Suppose we are in a big hall and there is a meeting is going on, there is a speaker and many are hearing their speech. Sometimes we can experience reverberation. What is the meaning of reverberation? It's a sound created in a big hall. For example, a sound created in a big hall will persist by repeated reflection from the wall until it is reduced to a value when it is no longer audible, isn't it? So the repeated reflection that result in this persistence of sound is called reverberation. If the hall is bigger, reverberation will be longer. We can hear how reverberation happens.
Sounds like when you are speaking inside.
So we have discussed what is the meaning of echo. How echo happens. If we look at this picture, we can identify how echo is happening. It touches an object, especially hard object, and coming back. Let's see an echo through an audio sample. What are the various factors which are affecting an echo? First one is the distance between sound source and the reflecting surface affects the time it takes for the echo to return. Suppose we are standing near a valley and opposite to us there is a mountain. The mountain is far away, it takes more time to return. And surface characteristics is also affecting the echo. Hard surfaces like walls or cliff reflect the sound waves more effectively than soft surfaces like carpets or curtains. And sound frequency. High frequency sounds tend to be reflected more easily than low frequency sounds. What is meant by an echo? If we want to sum up, echo is a sound that is reflected back to the listener after it is produced. It occurs when sound waves bounce off a hard surface like a wall, a cliff or a building, and it is returning to the original source. Application of echoes. In a system called SONAR, we are using echo. We are going to learn about SONAR. Echolocation, which are made by some animals. Here also we are using echoes. That is also we are going to learn now. In acoustic engineering also, architects are using principles of echoes to design concert halls and other spaces with optimum acoustics. SONAR. The full form of SONAR is sonic navigation and ranging. It's a technology used to detect or locate or track underwater objects. How it is functioning? It is functioning by emitting sound waves and listening for the echo that is returning from the object. So SONAR is used in Witchendall field for fisheries and oceanography. In fisheries, SONAR is used to locate fish school where fishes are available and assess how much fishes are available. And oceanographers, they are using SONAR for detecting or map the ocean floor and to study the marine ecosystem. We can see the picture of a sonar. From this ship, the waves are moving towards fish school, and waves are touching the fish school and coming back. And in that ship they will have a monitor. Through this monitor they can see the fish school and the seabed. In sonar, first the ship will emit a wave towards the object. Then the wave will touch the object and will return. And an analysis made. There will be a sonar device. That device measures the time it takes for echo to return, and calculate the distance to the object based on the speed of sound in water. And how can they see the result? Through a monitor which will display sonar image. Echolocation, which is a biological process which is used by some animals like bats, dolphins, or whales and all. Why they are using echolocation? How they are using echolocation? It is used for navigation, or to find out the prey, or find out the location, and to find any object in their surrounding. They emit sound waves, and they will listen to the echoes that will return after touching any object. It is actually sensory perception, similar to sight or hearing. This picture we can see a bat is emitting waves which is touching a object, which is butterfly, coming back. Bat is reflecting sonar waves. The red line is the reflected sound waves which is coming back, which helps the bat to identify the location of the butterfly. You can see that from these pictures how whales, dolphins, or bat is using echolocation for finding objects or location. A wave is transmitted to the object, and another small wave is coming back. Sometimes dolphins will whistle. That's actually a communication wave. Common example for echolocation are bats, dolphins, whales, etc. Ultrasound. What is meant by ultrasound? We might have heard several times, especially when we are going to the hospital, about ultrasound. It is also sound wave only, but with a frequency higher than the upper limit of human hearing, typically around 20,000 Hz. And ultrasound is used for many purposes. It is heavily used in medical imaging, and for industrial testing, and sonar. We have already discussed what is the meaning of sonar. In medical imaging, it can be used to create image of internal organs, isn't it? You might have seen ultrasound scanners, and if we want to create an image of internal organs or internal tissues, we can use ultrasound method. Here high frequency sound waves are transmitted into the body, and analysis is made by looking at the echoes that is returning. And it is to be noted that ultrasound is a non-invasive and safe way to diagnose varieties of medical conditions like pregnancy, heart defects, or liver diseases. Thank you all.